Number 1, we're asked to name the reflection image with respect to line L. So that's just asking us to look at the image they gave us, or the pre-image they give us, and then after it's reflected with line L, where does it end up? So C is reflected or flipped over line L will become point B. Number 3, BX. BX is a line segment. So if it's flipped over line L, it'll fall on top of CX. Now you have to say CX in that exact order because that shows you that B fell on top of C when it was flipped and X fell back on itself when it was flipped. If you put XC, that would be incorrect. Number 5, first we're going to graph the figure. A is 1, 2, B is 3, 2, C is 2, 4, and D is 4, 4. So this is our original figure, and after we reflect it, after we rotate it 180 degrees, XY will become negative X, negative Y, which is a rule that you have to remember. So we flip all of our points, or we just negate all of our points. This will become negative 1, negative 2. This becomes negative 3, negative 2, negative 2, negative 4, and negative 4, negative 4. So negative 1, negative 2 is A prime, negative 3, negative 2, B prime, negative 2, negative 4, C prime, and negative 4, negative 4 is D prime. Connecting our point gives us our final image. Okay, number 7, it asks us to name the reflection of L over the y-axis. So find point L, and we're going to flip it over the y-axis, so the vertical axis. So L is 1, 2, 3, 4, 5, 6, 7 points away from the y-axis. So we're going to go 7 points away from the y-axis in the other direction. 1, 2, 3, 4, 5, 6, 7. So that gives us a coordinate of 7, negative 1 over the y-axis. Okay, number 19. It says to find the image of BCDE under a dilation, so that means a reduction or an enlargement, centered at the origin with the given scale factor. So we take R and multiply it by 1, or we take our coordinates and multiply it by R, our scale factor, which is 1/2. So first let's determine what the coordinates are. We have negative 1, 2, 3, 4, 5, 6, and positive 2. We have negative 4 and positive 1, 2, 3, 4. We have 0, positive 2, and we have 2, positive 4. So if we have a scale factor of 1/2, we're going to take each of those coordinates and multiply it by 1/2, or cut it in half. So negative 6 becomes half of that, negative 3. 2 becomes 1. For point C, 0 divided in half is just 0. 2 divided by 2 is 1. Point D, 2 divided by 2 is 1. 4 divided by 2 is 2. And point E, half of negative 4 is negative 2. And half of positive 4 is positive 2. And so our image on the graph would be right here. Okay, so we have a regular octagon divided into 8 congruent triangles. To find the image of each point or segment using rotations, we first have to figure out what each of those angles is equal to, each of those central angles. So we take 360 degrees, because we know all the vertices centered around a point are going to be 360, and we divide that between how many angles there are, which there are 8. So we get a total of 45 degrees for each interior angle. So now when we're answering the questions, we just have to basically calculate how many degrees that's made up of. So here, 225 degree counterclockwise rotation of U about Z. So we have to figure out where's U going to end up after 225 degrees. So first we have to figure out how many 45s 225 is made up of. So 225 divided by 45 means that there are 5 rotations of 45 degrees. So we're going counterclockwise, that means we're going against the clock. So we go 1, 2, 3, 4, 5 rotations, and we end up at I. Okay, number 27, to determine the scale factor, remember we take our pre-image, so whatever, we'll take the side length of A prime, B prime, and we divide it by the image, we take the image and divide it by the pre-image. So then divide it by AB. So you just match the image's side length of 6 divided by the pre-image's original side length of 18. As a fraction, that reduces to 1/3. So A prime, B prime, C prime, D prime is 1/3 the size of A, B, C, D. And before you even start with this question, you could eliminate C and D because clearly this is a reduction. So remember, if it's a reduction, the scale factor has to be less than 1. Okay, number 29. How many lines of symmetry does a regular octagon have? The rule of this is a regular polygon has as many lines of symmetry as it does number of sides. So if it's a regular octagon, it's going to have 8 lines of symmetry.